Imagine you are standing on a beach in Brazil with a giant, indestructible shovel. You decide to start digging, not for treasure, but to reach the other side of the planet. You want to punch a hole straight through the earth to emerge in the middle of the ocean near the coast of China. It sounds like a fun weekend project, but you are about to encounter a series of physical nightmares that would end your journey almost immediately. First, let's talk about the distance. The Earth is nearly 8,000 miles in diameter. To get to the other side, you have to tunnel through the crust, the mantle, and the incredibly dense iron-nickel core. That is a lot of dirt. Even if you were a superhuman digger, you would hit your first major wall within about 20 miles. That is the depth of the Earth's crust in some places. Beyond that, you hit the mantle. This is solid rock, but it is under such immense pressure and heat that it behaves like a viscous fluid. It is essentially hot, pressurized taffy. As you dig deeper, the temperature starts to climb rapidly. By the time you reach the mantle, you are looking at temperatures between 1,000 and 3,500 degrees Celsius. Unless your shovel is made of some magical, heat-resistant material that hasn't been invented yet, you and your equipment are going to melt into a puddle of slag within the first few hundred miles. But let's pretend you have a magical suit that keeps you cool and an infinitely strong drill. You keep going. You reach the outer core. This region begins about 1,800 miles down. It is a swirling, liquid ocean of molten iron and nickel. There is no surface to stand on. You aren't digging anymore. You are swimming through liquid metal. The pressure here is massive, about 1.3 million times the atmospheric pressure at sea level. If you aren't perfectly shielded, you would be crushed into a speck of dust in milliseconds. Now, consider the physics of gravity. We tend to think of gravity as a force that pulls us toward the center of the Earth, and it does. But what happens once you pass the center? If you are falling through this hypothetical hole, you would accelerate as you approach the core, reaching a top speed of about 17,000 miles per hour. By the time you hit the absolute center of the Earth, you would be weightless, because the mass of the planet is pulling on you equally from every single direction. You would hover in a state of perfect equilibrium. But that weightlessness is fleeting. Your momentum would carry you right through the center. Now, gravity is pulling you backward toward the point you just passed. You would start to slow down. Eventually, you would reach the surface on the other side of the world, specifically at the antipodal point in the Pacific Ocean. You would arrive there with exactly the same speed you had when you started, 0. If you didn't grab onto the edge of the hole the moment you reached China, you would start to fall back down. You would oscillate back and forth like a human yo-yo, swinging from Brazil to China and back again for eternity. It would take roughly 42 minutes to make a one-way trip. Let's address the air. You might think you could just jump in and fall, but physics says otherwise. An open hole through the center of the Earth would be filled with air. As you fall, you would hit that air. At 17,000 miles per hour, that air acts like a solid wall. The friction would generate enough heat to incinerate you long before you ever reached the center. Even if you managed to survive the heat, the air pressure at the bottom of the hole would be so high, it would be like being at the bottom of an ocean thousands of miles deep. You would be compressed into a shape that would be very difficult to identify as a human being. Then there is the Earth's rotation. As you descend, you are moving with the Earth's surface. The surface at the equator moves at about 1,000 miles per hour. As you move toward the center, the path you are traveling becomes smaller. Because of the Coriolis effect, you would be slammed against the side of your tunnel constantly. You wouldn't be falling in a straight line. You would be scraping against the walls of your hole at thousands of miles per hour. You would need a very smooth tunnel, or you would be pulverized against the rock within seconds. So, why hasn't anyone done it? The deepest hole humans have ever managed to drill is the Kola super deep borehole in Russia. It was started in 1970 and reached a depth of just 7.6 miles by 1989. It took them nearly 2 decades to get that far. At that depth, the rock became so plastic and hot that it behaved like a liquid, causing the drill bit to snap off or melt repeatedly. They stopped because the equipment couldn't handle the heat. 7.6 miles is impressive, but it is less than 0.2% of the way to the center of the Earth. We have barely scratched the skin of our own planet. We have explored more of the surface of Mars and the Moon than we have of the depths beneath our own feet. We know what the core is made of, largely through seismology, measuring how earthquake waves bounce through the planet's interior. We are looking at a shadow of the Earth's anatomy, not the actual organ. If we ever do develop the technology to drill deeper, we wouldn't be doing it to build a shortcut to China. We would be doing it to tap into the geothermal energy of the mantle or to understand the magnetic field that protects our atmosphere from solar radiation. The Earth's magnetic field is generated by the churning liquid iron in the outer core. If we could understand that mechanism better, we might solve our energy problems for the next billion years. But for now, the center of the Earth remains an alien world. It is a place of impossible pressures, molten oceans, and gravitational paradoxes. It is a reminder that while we have mapped the stars and sent probes to the edge of the solar system, we are still very much tethered to the surface of a giant spinning rock that we don't fully understand. So, the next time you feel like digging a hole in the backyard, remember that you are doing more than just moving dirt. You are reaching down into a dynamic, shifting, and incredibly violent engine. The Earth is not a static ball of stone. It is a living, breathing, heating system that has kept us safe for 4.5 billion years. Maybe it is better that we keep our shovels on the surface and leave the core to the molten iron and the mysteries that lie within. If you could actually make that journey, would the discovery be worth the risk, or are some depths simply meant to stay buried?